Break apart factors. Use place value products. Add partial products.
When you first look at a large multiplication problem, the sheer size of the numbers can feel a bit overwhelming. Trying to calculate a massive total all in one giant leap is a quick way to get stuck. But here in the gridded garden, we handle big numbers a little differently. This is Pip the fox, and under the watchful eye of Kit the wise math Sheba, he is going to show us how to bring big numbers down to earth. We simplify these problems by deconstructing large numbers into their core place value components, their hundreds, tens, and ones. It all comes down to one reliable routine. Split it by place value, multiply each piece, and add them back together. This sequence is designed to keep the math manageable, no matter how large the numbers get. Let's see this in action with our first challenge, finding the total of 4 times 213. This diagram shows our problem built as a rectangle. We take the long side, the 213, and physically split it into its base place value bands, 200, 10, and 3. Now we multiply each segment by 4, starting with the largest. 4 times 200 gives us a partial product of 800. Next, we move along the rectangle to the tens band. 4 times 10 yields 40. Finally, we multiply the smallest segment. 4 times 3 is 12. We have our 3 separate partial products. To find our final answer, we just add them back together. 800 plus 40 plus 12 gives us 852. What we just proved mathematically is also true spatially. The total area of a rectangle is exactly equal to the sum of its smaller separated bands. We can apply this exact same logic when both numbers have 2 digits, 24 multiplied by 36. Looking at this new grid, the process requires us to split both sides. The length breaks into 30 and 6, while the width breaks into 20 and 4. By splitting both dimensions, our original rectangle transforms into a grid of 4 distinct plots. To get the correct total, every part of the length has to multiply with every part of the width. We calculate the primary plots first. 20 times 30 creates a large plot of 600. Right next to it, 20 times 6 gives us 120. We can also apply this consistency to much larger problems, like calculating 3 multiplied by the 4-digit number 1,250. This wide area model lays out our plan. We take that larger number and break it down into its constituent parts, 1,000, 200, and 50. We calculate across the scale. 3 times 1,000 is 3,000. 3 times 200 is 600. 3 times 50 is 150. We combine these partial products, 3,000 plus 600 plus 150, and arrive at the final sum of 3,750. The process remains the same regardless of the number of digits involved. By splitting the work into place value pieces, you can reach the correct total for problems of any size. Looking at this landscape, you can see the evidence of our 3 challenges. Whether a problem was wide, 2-dimensional, or in the thousands, a single repeated action reliably dismantled every one. Break the numbers into their place value pieces, multiply every single piece, and add the resulting products back together. This is the area way. It translates abstract strings of digits into a physical space you can navigate, giving you a permanent geometric tool to map out your math. By mastering this simple act of splitting by place value, the spatial logic behind all complex multiplication is entirely in your hands. See you in the next field.
Multiply each place. Track the zeros. Combine the parts.